Hello everyone, my name is Mr. Bice with Susquehanna Valley High School here in Concord, New York, and there's my email address. We're doing Unit 12, Lesson 5, Common Core Algebra 2 Non-Regents. If you don't understand what I'm saying, just scan that QR code. You can listen to the great teacher that made these worksheets. You have to listen to me. Listen to me. This is something very difficult to understand. We're doing independent events. I say it's difficult to understand because you can always think of an exception. Do not think of exceptions. Okay, we're going to follow exactly what the question says. Don't say, but what if? No, do not change the question. Okay, so in the previous lesson's homework, we say that the occurrence of one event could change the probability of another event. When this happens, we say the two events are not independent. I also say they are dependent on each other. When the occurrence of one event has no effect on the probability of another event happening, we say they are independent. Classify each of the following scenarios as events having dependent or events that are independent. Okay. Person pulls red marble out of a bag that has 5 blue and 7 red marbles and does not replace it. Then a person pulls another red marble. Is the probability of pulling the second red marble out dependent on pulling the first red marble? Please explain. Yes. Okay. There are 12 marbles in the bag to start off with. 5 plus 7. 7 of them are red. That's the odds of getting the first red marble. Now, if they were independent, then the odds of getting the second red marble out would also be 7 out of 12. But how many marbles are in the bag the second time? There are only 11 marbles. How many of them are red? 6. They do not equal each other, so they are dependent. The probabilities don't equal each other. A person flips a coin and notes it and comes up heads. A person rolls a standard 6-sided die and notes that it comes up as number less than 3. Is the probability the number came up less than 3 depending on getting a heads on flipping the coin? Let me see. Explain. Well, the probability of getting the coin, probability of getting the heads, is 1 out of 2. The probability of, let's say, less than 3 is 2 out of 6. Okay, now, what if I got a tail? What's the probability of getting a less than 3? Probability of getting a less than 3 still is 2 out of 6. Let's say I don't even flip the coin. No coin. What's the probability that I get less than 3? It's still 2 out of 6. 2 out of 6 equals 2 out of 6 equals 2 out of 6. Every scenario possible does not change the outcome. It's going to be 2 out of 6. The idea of independent, wait, did I answer this? Independent. The idea of independence is one that comes fairly naturally, but it's important, naturally for some people. But it's important in order to see if there are associations among two events. An association, a relationship. Let's develop a tool to test dependence. Spin or blow is spun once. Now, I told you, you have to listen to me. We cannot change the question, okay? You can think of a way to change this question so that the answer comes out differently. We do not want to change the question. If you change the question, you will change the answer. Okay, The spinner blows spun once and the outcome is noted. E is even. E is even. P is prime. L is less than 5. Find the following probabilities. The probability of getting an even number. Okay. Even, 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 even. 4 out of 8. They're probably getting an even given that the outcome was prime. Prime, 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 prime. There are 4 primes. There's one of them that is even. We're only looking at the primes. That's what that means. We're only counting the primes. Do not change the question. That's probably getting an even given that the outcome was a number less than 5. Less than 5, less than 5, less than 5, less than 5. That is, there are 4 numbers less than 5, and 2 of them are even. Which event does even depend on? Prime or less than 5? To understand, which event does even depend on? Prime or less than 5? How can you tell? What's a reasonable test? Let's figure out what depend means, or dependence. So let's say you hand me your global test. I grade it. Does your average in class change? Not at all. Your average in math does not depend on how well you did on your global test. That's what dependence means. It will change or it won't change. If you depend on something, then it'll change the answer. So let's see how many of these change the answer. Here is the probability of even. The probability of even equals 4 out of 8. Now, I'm just going to simplify that to be 1/2, even though you know I hate that. Okay? But the probability of even, given that it's prime, equals 1/4. Oh, that changed. Okay? The probability, given it's less than 5, the probability that it's even, given that it's less than 5, is still 2/4, which is 1/2. And that's not changed. So, which event does even depend on? The probability that it's prime. Because the answer changed. On to the next page. I told you before, we have to answer the question that is asked. We can't change the question. Okay, so we're going to answer the question that is asked. We saw this 3 pages ago, the definition of independent events. And this says, what is the probability of A given that B happened? Okay, and it equals just the probability of A. So did B really matter? No, it didn't matter at all. If B happened, if B didn't happen, it's still just the probability of A. Here, what is the probability B is going to happen given that A happened? It equals the probability of B. So again, A did not affect the situation at all. So a survey of 57 sixth graders was done to determine which subject was their favorite. The results are shown in the table below, sorted by gender. There's the table. Does it appear? It doesn't mean it has to be a fact, just does it look like, based on the data in this table, that the preference for math as a favorite subject has dependence on a student's gender. Show the analysis and explain your findings. Okay, so what we're going to do is we're going to take, does it appear that it's based on the data for a student's gender? So let's take a female, and the fact that it is 8 out of 57, that's the probability of A. Does that equal the probability of A given that they are a female? And this, the probability of A given that they're a female, is 8 out of 30. And no, they don't equal each other. Okay, I made just a little mistake here. This is supposed to be 18. Do they like math? The probability that they like math. Probability that they like math. 18 out of 57, given the restriction that they're a female, that they like math. Okay, so 18 out of 57 does not equal 8 out of 30. If you don't know that the decimals don't equal each other, there it is. We don't have to check male because we already proven that it doesn't based on gender. It's females is a gender, so it doesn't work. Does it appear based on the data of this table the preference for social studies as a favorite subject has dependence on student's gender? Social studies. Here we have social studies, 19 out of 57. Does 19 out of 57. Does that equal 10 out of 30? Geez, this isn't supposed to be 57. I was said 57. There we go. Do the division, and we have, yes, we can simplify this fraction. They're both 1/3. 1/3 equals 1/3. I'm going to speed this up a little bit. Given that A depends on B, if they are independent, then the probability of A times the probability of B equals the probability of A and B. Only if they are independent. Okay? So, if the probability the person is left-handed and the probability they have brown eyes, the probability they are both is 2%. Are they independent? This proof, this formula over here on the left-hand side, A, must be true. The probability that they're left-handed times the probability that they have brown eyes has to equal the probability of L and BR. So let's see if that's true. The probability that they're left-handed is 0.12 times the probability that they have brown eyes is 42 hundredths. Both is 2 hundredths. So let's see if they equal each other. this is approximately 500ths, does not equal 200ths. They are not independent. If they were independent, they would equal each other. Again, we cannot change the question because we don't like the answer. If you have any questions for me, make sure you ask me in class. Have a great day.